by the symbol I, and this means what? It is the rate of flow of charges. This means that it is the rate of flow of charges. It means what? Rate of flow means what? That if you have a wire with you, if you have a normal cross-sectional area, a wire with you, then amount of charge that flows through it. So that flow of the charges, that is known as electric current. So basic formula of electric current is I is equal to Q divided by T. So this is the rate of flow of charges. Now, one more thing, if this is a wire, this is a wire, at t is equal to 0 means initially I have started the timer, and exactly at t is equal to 1 second, I have stopped the timer. Now, during this duration from 0 to 1 second, there must be some amount of charges that have flown through the wire if I have switched on the circuit already. So, certain amount of charge must have flown through this wire. Now, these amount of charges that have flown through this wire for the duration of 1 second, this is known as what? This is known as electric current. So electric current is what? Electric current is the amount of charge that flows for a duration of 1 second. That's why we say it's the rate of flow of charges. Electric current is the rate of flow of charges. Now, apart from the basic definitions of electric current, you have to remember that the SI unit of electric current is what? It is ampere, denoted by the symbol capital A. And electric current's symbol is I, SI unit symbol is A. So you will see 4 ampere, 5 microampere, 3 milliampere, like this currents will be mentioned, especially when we'll be using the devices like ammeter, voltmeters. These milliampere and microampere will get used, but that you will study in your magnetics. One thing, this is a scalar quantity. Now, physical quantities are grouped into two categories. One is the vector quantities, other is the scalar quantities. So vector quantities are those quantities that have magnitude, they have direction. Regarding the scalar quantities, they only have the magnitude. But let's talk about the direction of electric current. There is a certain direction of current. Let's discuss that. Now, if there is a positive charge, let's say the positive charge is moving in some direction. Let's take it as rightwards. Let's say this positive charge is moving towards the right with v velocity. So direction of electric current will be the same as that of motion of the charge. Means if the charge is flowing towards the right, current will be towards the right. If this positive charge is flowing upwards, then the direction of electric current is also upwards. Whereas if this is the case for a negative charge, if the negative charge is flowing towards the right hand side, then direction of current is opposite to that of flow of motion of the charge. So if this was flowing towards the right hand side, for current, the direction will be towards the left hand side. Or if the charge, not the positive, the negative charge, if this negative charge is flowing towards the, it's flowing upwards, let's say, then the direction of electric current becomes downwards. So remember, if you have particles like protons, you can use this direction. If you have particles like electrons, then you have to use this direction. Means whatever is the flow of charge, you have to reverse the direction. Now, coming back to this point, whether it's a scalar quantity or a vector quantity, see, according to this fact that electric current has a magnitude, and magnitude can be calculated using this formula, and it also has a direction also we have studied right now. So according to both of these points, electric current should be a vector quantity. It has a magnitude, it has a direction. Just the difference point, the differential point that makes electric current different from other vector quantities is the fact that it does not obey the vector laws. Vector laws you people must have studied in class 11th. No, parallelogram law. We'll also have a revision class for that. So anyone who wants to revise it, you can join. We already had a revision class earlier, but for the new students, there will be one more class. So you people can join. So vectors are what? Vectors laws are what? Parallelogram law, all these laws. Now, regarding this electric current, so since it does not obey the vector laws, it has a direction, it has a magnitude, but it does not obey the vector laws, we categorize electric current under the category of what? Under the category of scalar quantities. So it's the only scalar quantity, this electric current, this is the only scalar quantity that has a direction as well as a magnitude. So just note down these introductory points, then we'll see how is this formula used, because obviously this formula will not be just directly or randomly used. So note the point still here, then we'll discuss it.
Ma'am,
Yes, Anushka, say.
ma'am, could you explain the direction again?
Yes, sure. The direction for a positive charge, whatever is the direction for a positive charge, no, wherever this is a positive charge that is moving across the wire in this manner, in this direction, some random direction. So direction of current will be also this, exactly the motion of the charge wherever this charge is moving. But if we have a negative charge and negative charge is moving in this direction, this is some random direction that I've taken, this is neither north, south, east, west, or any of these, random direction I've taken, so electric current becomes opposite to it. So direction of current is useful because direction of current is also asked in your exam in your 1 markers. Whatever is the direction of flow of charge, direction of current, we say opposite for a negative charge and along the same line of motion for a positive charge. Now clear?
Yes, ma'am.
Now see the formula that I've told you, I is equal to Q by T. So it's not used directly in the exam, I is equal to Q by T, because it will be a very, very easy question then. If you people are fortunate enough that the paper is very easy, then definitely this formula will be used directly. That value of charge is given, time is given, directly write down the value of the current. But how does this formula is used is two things you have to understand. First thing, this is known as time duration. Now, time duration means what? Time duration means that there's a starting of a time and ending of a time. For example, I'll say that our class started at 11 a.m. and our class ended at 12 p.m. So the class started at 11 a.m. and the class ended at 12 noon. This means what? There is a starting. 11 a.m. becomes the starting. 12 noon becomes what? It becomes the ending. So that gap is known as time duration. What we'll say? We'll say our class of was 1 hour duration or 1.5 hours duration or 2 hours duration. Like this, we say the duration. So duration means what? That time is 0 to 8 seconds, 4 to 5 seconds, 3 p.m. to 4 p.m. Like this we say. This is known as time duration. So in your exam, if time duration is mentioned, 3 hours to 5 hours, in this manner, any time duration is mentioned, then the current is given by change in the charge divided by the change in the time. Means final charge minus initial charge divided by the time duration, that is final time minus initial time. And the type of current we get over here, we call it as average current. Now, contrary to this, we have a concept of time instant. Time instant means what? Exactly at a particular second, exactly at a particular moment, you are finding out the value of current. For example, if I ask you to find out the current at, this was what? Between 0 to 8 seconds. If I ask you to calculate the current exactly at 8 seconds, or if I ask you to calculate the current at 0.0001 seconds, or t is equal to 3.0004 seconds. Like this, if I ask you a very precise time, it can be any time, t is equal to 3 seconds, like any time I'm asking you. So there you have to, this is known as time instant. So if time instant is given to you, then we differentiate charge with respect to time. Normal differentiation that you have studied from your calculus. And this type of current that we obtain here, this is known as instantaneous current. Now, for example, how is this calculated? I'll show you a question. See, this question says what? Charge flowing through a cross section of conductor is Q is equal to 3t square plus 2t plus 1. This is mentioned. Now, current in 0 to 2 seconds is given. Second part is asking to calculate the current at t is equal to 2 seconds. So are you able to notice? This is what? Time instant or time duration? This first part. Is it a time instant given to us or time duration?
Time duration.
Time duration, exactly, Anushka. This is a time duration that is given. So if time duration is given, we calculate the average current. Average current means final charge minus initial charge. Final charge will be at t is equal to 2 seconds. So just put 2 everywhere. 3 into 2 square plus 2 into 2 plus 1. This becomes what? 12, 16 and 1, 17. 17 coulombs. Let's calculate the initial charge. Initial charge is at t is equal to 0 seconds. So put 0 everywhere. So this becomes 3 into 0 square plus 3 into 0 plus 1. This is equal to 1 coulomb. Now the current, average current. This is given by change in charge divided by the change in time. Final charge minus initial charge divided by final time minus initial time. From 0 to 2 seconds, you can easily predict that the time duration is 2 seconds. So this becomes 16 divided by 2, which is 8. So average current comes out to be 8 ampere. Now, for the second part, it is given current at exactly at you have to find t is equal to 2 seconds. So here we have to perform differentiation. Are you people clear with differentiation? Abdullah, Anushka, Laya.
Yes, ma'am.
Clear? Anushka, what about you?
Ma'am, it's a little bit difficult.
Little bit difficult. All right. Fine, Anushka. So we'll keep on trying it as the questions come. For example, here a question has come, so we'll try to do it together. So charge is what? We have to differentiate charge with respect to time. Charge is given to as 3t square plus 2t plus 1. So we have to differentiate charge with respect to time. See, if x is to the power n, when we differentiate this x with anything, let's say time or anything, n comes out and gets multiplied with this term, and we don't leave this term like this. We subtract 1 from the power. This is the rule of differentiation. If you have a constant term and if you have a function, this is a function, this is a constant. So constant term stays, and we now have to differentiate t square. So see, Anushka, Abdullah, see, to the power n, here the n becomes 2. T square is left, and what did I say? We subtract 1 from the power. Subtract 1 from them. So what is left? 2t to the power 2 minus 1, it becomes 1. This much. First tell me, is this clear?
Yes, ma'am.
Clear? All right. Plus 2. 2 is a constant. T to the power 1. See, t to the power 1 is there. So that becomes 1 into t to the power 1 minus 1. T to the power 0. Any number multiplied by 0 to the power 0 is 1. So this is 2. And this is a constant. When we differentiate a constant, we get 0. So current is what? 6t plus 2. We have to find current at t is equal to 2 seconds. So current becomes 6 into 2 plus 2, which becomes 14. So instantaneous current comes out to be 14 ampere, whereas your average current came out to be 8 amperes. Dear class, so note down these points. Wherever you're not able to understand, ask me. Clear your doubts. Done?
Yes, ma'am.
All right. So this was electric current. Now just understand what is meant by drift velocity. Then we'll see the derivation. We'll see a quick derivation for it. But understand what is meant by drift velocity. Now see, a normal wire is this. Now I am drawing an enlarged section of a wire. This is a normal wire diagram. Wire that we have. Now, in a wire, what all things are present? If there's a wire, then there are positive ions that are present. Apart from this, there are negatively charged electrons which are present. Fine. So what happens as we connect this, as we connect it to the battery, as this wire is connected to with the help of to the battery, what happens? Because of electric field, these electrons begin their motion. They begin their random motion. Some electrons collide with themselves. Certain electron collides with the positive ions like this. Certain electrons collide with the walls of the conductor like this. Random collision begins between the electrons. So what happens in this movement, in this motion, each electron will be having its own velocity. Let's say v1 is the velocity of this electron, v2 is this, v3 is this, v4 is this, v5 is this, so on. Nth electron, it is vn. Now, if I ask you what's the velocity of the electrons that is flowing through the wire, you won't tell me a single velocity. You cannot mention v1, v2, v3 or any one of the values. Why? Because these values are for each electron. If this electron is moving, or let's say 5 meter per second, it can happen that this electron must be moving with velocity 4.9 meter per second. This electron must be moving with velocity 5.02 meter per second. So roughly they all are moving with the same velocity, but in actuality, every electron is moving with a different velocity. So how to tell? If I say you three had a test, Abdullah scored 95 on 100, Anushka scored 98 on 100, Laya scored 97 on 100. This was the sequence of marks. So if I have to tell the marks that is obtained by all of you, so I'll tell the average of the 3 marks, 95, 97, 96, 98, whatever values I said, these marks. Similarly, if every electron has a different velocity, so we will tell the average velocity. We will use the average velocity that is flowing within this cross-sectional area of wire. And that average velocity, so what happens? Every electron will get attracted towards the positive terminal of the battery because negative will be attracted towards the positive. So what happens? This average velocity with which the electrons drift towards the positive terminal of the cell. This velocity, this is known as drift velocity. This velocity, it is known as drift velocity. Clear? So there's a quick derivation for it. This derivation is lengthy, so many a times it is not given in the exam. See, initially all the electrons are at rest because they are not moving from the starting. So initial velocities of all these electrons, this is equal to 0. Now, force is equal to what? In your first lesson, electric field and charges, force is equal to QE. You must have heard of this relation. acceleration is equal to force divided by mass. From this, F is equal to ma, Newton's laws of motion. So if you put in the value, acceleration becomes equal to what? QE divided by m. Now, charge for an electron is E, which is the electronic charge. Electric field is capital E divided by m. See, this will be used. This is important. This will be used. Now, one more thing. See, when the electrons collided among themselves, when this collision began, there was a collision over here. All of you agree with that point. So when the collision began, what happened? As the collision began here, when these electrons were moving, once it collides, let's say it has collided with this, then there will be a certain time gap before the next collision begins. There's a very slight time gap before this electron collides with another particle or the wire or anything. That small time gap, this is known as relaxation time. That small slight time gap, that is known as what? That is known as the relaxation time. So this relaxation time is different for every electron. So for all the electrons, we'll call it as the average relaxation time. This will be for all the electrons. So here also, tau 1, tau 2 are the relaxation times. So using the uniformly accelerated motion equation, this is from uniformly acceleration motion equations. V is equal to U plus AT. So for the first electron, V1 will be equal to U1 plus A tau 1. For the second electron, V2 will be equal to U2 plus A tau 2. Similarly, for nth electron, UN plus A tau n will be the velocity. So what's the drift velocity? Drift velocity is basically the average of all these velocities. So if there are n number of electrons that are present, n is the number of electrons that are present. So velocity will be V1 plus V2 up till Vn divided by the number of electrons, that is n. So here we'll have, see, Vd drift velocity will be equal to Vn plus V2 up till Vn divided by n. Let's put in the value of V1, V2, Vn. So you will get U1 plus A tau 1 plus U2 plus A tau 2 up till UN plus A tau n divided by n. Now, if we separate all the like terms together, initial velocities together and the A tau 2 together. See, this term is what? This is the initial velocity, average of all the initial velocity. That will be equal to 0. Average initial velocity will be equal to 0. And this term, this is what? This is the relaxation times average. So we denote it by a single symbol, that is tau, which is known as average relaxation time. So drift velocity becomes equal to A into tau. So from here, we had calculated the value of acceleration, no? E divided by m. From here, you can have the value of acceleration as E capital E divided by m into tau. Now see, what does each term mean over here? This is what? This is the drift velocity. This negative sign symbolizes the fact that drift velocity's direction is opposite to that of electric field. That's why we have added this negative sign to that of electric field. Capital small e is the electronic charge. And what is the electronic charge? That is 1.6 into 10 to the power minus 19 coulombs. M is what? M is the mass of electron. And mass of electron is also fixed. That is 9.31 into 10 to the power minus 31 kg. Capital E is the electric field. Electric field is what? It's the space around a charge where electrical phenomena are experienced. And tau is what? Tau is the average relaxation time. Fine. So this is the formula of drift velocity minus E capital E tau divided by M. This is the final formula. So note down the derivation. This derivation is a lengthy derivation. From here. Yes, class, done? Any
Yes,
doubts
ma'am.
till now? Drift velocity, electric current, basics is clear. See, there's one more derivation. This is a very easy derivation, and this comes a lot. This comes more than your drift velocity. This relation between current and drift velocity. See, drift velocity's derivation usually does not come in the exam because this is a very lengthy derivation, but it can also come. Relation between current and drift velocity is very frequent. Most of the students that had their unit tests, no, this question was already given. Now see, what's the relation between drift velocity and a current? So if length is this of a conductor, means the wire's length is L and A is the cross section area. So see, speed is what? Speed is distance divided by time. If speed is distance divided by time, then time will be equal to distance divided by speed. So time taken by an electron to begin from one end of a wire and reach the other end of a wire, this will be what? Length divided by the drift velocity, because the velocity over here is the drift velocity. So time is equal to length divided by Vd. Q is equal to Ne. This is from the quantization of charge. This is from the quantization of charge. Now, quantization of charge means that if n is equal to 1, means a single electron is there. Charge will be equal to 1.6 into 10 to the power minus 19. If there are 2 electrons, then charge will be 2e. That is 2 into 1.6 into 10 to the power minus 19. Similarly, n number of electrons are there. So that the charge on all the n number of electrons will be Ne. That is n multiplied by 1.6 into 10 to the power minus 19 coulomb. So if the volume will be what? Area multiplied by the length. That's how the volume for a cylinder is given. So for a cylindrical wire, the volume is given how? Length multiplied by the area. So volume, this is the volume. Volume is given by A into N. So if charge for a single electron over this area, this is Ne, and for the entire wire will be what? Just multiplied by the volume. So the charge becomes what? NeAl. And time is what? L by Vd. Charge is NeAl, time is L by Vd. Now see the main formula of current. Main formula of current is what? Charge divided by time. So see over here, charge, if you put the value of charge as NeAl and time as L divided by Vd, L gets cancelled, current is equal to NeA Vd. Now see, if I ask you people, what do you think is the relation between current and area of cross section? Do you think they are directly proportional? They are inversely proportional? What do you think using this formula? Just tell me. A is the area and I is the current. What do you think? Current and area are directly proportional to each other, inversely proportional to each other. What do you think? Yes, class. Anushka, you want to try?
Ma'am, directly proportional?
Directly proportional. See, class, when we look at this formula, now it seems that current is also here, area is also here. So current and area should be directly proportional to each other. But what happens is that current is actually independent of area of cross section. So even if there is a wider end and there's a narrower end of a wire, this is A1, this is A2. Even if we say that A1 is greater than A2, current will be independent. If I is the amount of current that flows from here, I will be the amount of current that will come out from here. So don't go through this, that current is directly proportional to area. This is an important point that is important for your theoretical questions. Now, drift velocity seems inversely proportional to area, no, from here. This is valid. If A1 is greater than A2, then VD2 is greater than VD1. Means if the area is more, velocity will be less. Area is less, velocity will be more. This is valid. So these are some of the important conclusions that are from this formula, and this is a very important relation and a derivation. I is equal to NeA Vd. Quickly note this down. Yes, class, written this much? Anyone is still writing?
Ma'am, I'm done.
Done? Okay, I'll just take 5 more minutes. One very important topic, that is this law. Just this law that I've already discussed with you when we were discussing all the circuits yesterday also and day before yesterday. So Ohm's law is actually what? At constant temperature and pressure, potential is directly proportional to the current. This is Ohm's law. And the constant that we get here to remove the proportionality sign, this is R, which is known as resistance. So Ohm's law is what? V is equal to IR. Yesterday we have used this law a lot, so I think most of you must be remembering it, but this was important to mention. This constant that we get is known as resistance. This is known as current, and V is the potential difference. And this statement, this is known as Ohm's law. Fine, class. So just quickly note down this. When you all three have written, just text me done in the chat box and I'll stop the class. Done, class, written? Abdullah, Anushka, Laya.
Yes, ma'am, done.
Yes, ma'am.
And what about you, Abdullah? Written? So see, class, so I'm stopping the class over here. The next topic is resistance and resistivity and internal resistance, EMF, potential difference. These small topics are there. So those video lectures I'll send you. We have the next class directly on Saturday. So you have this